Welcome to our second probability distribution video for normal distribution. We're going to talk about the standard normal distribution, which is a normal distribution curve that has been converted to get a mean of 0 and a standard deviation of 1. Useful when we compare different data sets and helps us solve more complicated problems. Now, the standard normal distribution uses the following formula. Z is equal to x minus mu divided by sigma. Z represents the number of standard deviations we are away from the mean. Now, here's the example we're going to solve. The height of 1,000 Year 12 students is normally distributed and has a mean of 168 centimetres and a standard deviation of 8 centimetres. We're going to work out the probability a student is greater than 180 centimetres. Now, we can solve it on the graphics calculator as we showed you in our previous video, but we're going to solve this with the standard normal distribution. So let's start off with our formula. Z is equal to x minus mu over sigma. So let's substitute 180 for x, which is the number we want to be bigger or smaller than. 168 is the mean, mu, and 8 sigma, the standard deviation. That gives us a z value of 1.5. Now, what does that mean? Let's redraw the graph with a mean of 0 and our z value out here at 1.5. Now, that tells us how many standard deviations we are away from the mean. We know that one standard deviation is equal to 8 centimetres, so half a standard deviation must be equal to 4 centimetres, and 1.5 standard deviations is equal to 12 centimetres. So we can see in the real world we're 12 centimetres above the mean, but in the standard normal distribution world we're 1.5 standard deviations away from the mean. All right, now we come to our tables. These are called standard normal distribution tables, and you'll get given one on your formula sheet. Let's show you how we read them. This is the formula, by the way, that calculates from your graphics calculator and used to determine them. You don't have to remember this. All right, let's go through some examples. If Z ever came to be 0.8, you'd race down to 0.8 and get a probability of 0.2881. If Z ever came to be 1.32, you'd race down to 1.3 and then come across into the middle to 0.02, and you get a probability of 0.4066. If Z ever came to be negative 1.56, the negative's important, but you don't need to use it for the table. It just tells you you are below the mean, and therefore you just need to find 1.5 and go into the middle to find your 0.06. And that gives you a probability of 0.4406. Now, for our example, we got a Z value of 1.5. So we're going to race down and get 1.5, which gives us a probability of 0.4332. Now, the problem is it's not the answer. It's the probability between the mean and our Z value. So that's this region here. That's 43.32%. Now, we know there's 50% of the data from 0 and above, so we're going to be clever and just subtract that away from 0.5 because 0.5 represents 50%. So 0.5 minus the 0.4332 leaves us the remaining bit, which is 0.0668. And we can come back and compare the probability of Z being greater than 1.5 is 0.0668, which is very close to what the graphics calculator gave us. Right, one final thing I wanted to leave you with is we can get a little bit more accurate with this, and we can use what's called the difference column. So let's say Z came to be negative 1.125. Again, don't worry about the negative because that just tells us we are below the mean. So we're just going to look up 1.12. We can go to the first two decimal points and get 0.3686. But if we want to be a little bit more accurate and go to the next decimal point, which is 5, we'd race across to the difference column and get to this number 10. And basically, we want to take that 0.3686, treat it like 3,686 and add on 10. So the probability is going to give you 0.3696 as the answer. All right, well, that's us for standard normal distribution. So thanks so much for watching.